So we're AGRIPURE, or white team. Antimicrobial resistance has been making the news, and while we may hope that headlines such as antimicrobial resistance a greater threat than cancer by 2050 are dramatised, antimicrobial resistance is a real and immediate threat. Antimicrobial resistance is already responsible for 25,000 deaths in Europe annually, and the 2014 Antimicrobial Resistance Report estimates that by 2050, 10 million deaths will be attributable to antimicrobial resistance. Antimicrobial resistance develops when some cells in a population of microbes are not affected by an antimicrobial due to natural resistance or chance mutation. When a patient is treated with an antimicrobial agent, these cells will survive, reproduce, and body's defences will not be able to overcome the infection. This is a problem for healthcare professionals as it limits the number of treatments they can use to treat diseases. While we typically hold inappropriate prescriptions and patient misuse responsible for the rise in antimicrobial resistance, agriculture is also partially responsible. Antimicrobial agents have been used in agriculture, in livestock and poultry farming since the early 1950s to treat disease, improve growth and improve feed efficiency. Antimicrobial resistance can be passed on, resistant microbes can be passed on to humans through direct contact or through the consumption of meat and manure-treated products, as resistant bacteria can pass into slurries and manures. And this is a problem because according to the US FDA, there are only 25% of antimicrobials used in agriculture have no direct overlap with human medicine, meaning that we could be exposing ourselves to bacteria that are resistant to antimicrobials important in human medicine. And there is a further indirect threat as a result of animal excretion. Both resistant bacteria as well as significant volumes of antimicrobials are passed into manure, with most of the active ingredient of the antimicrobial left unmetabolized. This means that we are releasing resistant bacteria as well as antibiotics onto our soils, increasing the chances of developing resistance in bacteria outside of the confines of the animal's gut. So in order to reduce the spread of antibiotics into the environment, the review on antimicrobial resistance calls for consideration about the use of byproducts which may contain antimicrobials, such as manure from animals that have been treated with antibiotics. However, animal waste is an important source of nutrients that are required for crop growth, and the application of organic materials is recognised as crucial for maintaining soil condition. Therefore, while discouraging farmers from using byproducts from animals who receive antibiotics would reduce the environmental load of antimicrobials, this approach would also deprive the soil of an important source of nutrients and organic material. So we have developed a product that eliminates the passage of antimicrobials from slurries onto soils. And this product is targeting slurries because they're one of the most commonly used forms of animal waste in the UK. We have targeted the antibiotic tetracycline, which is a broad spectrum antibiotic used commonly in the treatment of urinary tract and respiratory tract infections. Since 1969, the veterinary use of this antibiotic has increased tenfold, and in 2014 it was responsible for 40% of sales of antibiotics in the UK. So tetracycline was a natural target for our product.
So this is just a little diagram to show. To show that tetracyclines are a really important type of antibiotic. So the product that we have developed uses the latest AGRIPURE technology to create high affinity reusable filters that will clean antibiotics out of slurry. The filters will be custom made to fit into the pipes that will fit into the machinery that spreads the slurry onto the farms. And this is just one of the examples. And this is the pipes you can see that will distribute the slurry onto the fields, and our filters will fit into these. We will source our aptamers from a local startup company based in York called the AGRIPURE, and this means that our business will help to support other local companies. So what are aptamers? Well, this is the aptamer group's definition of aptamers, and a less wordy definition is to help to describe them as similar to antibodies in our immune system. They work by recognising and binding to small molecules with really high affinity, and that makes them great for their use in a filter. So we've chosen aptamers rather than antibodies for several reasons, and we think that this is going to make our product a lot cheaper and a lot more effective. So aptamers are nucleic acids, they're not proteins, which makes them a lot more stable. They also have a long shelf life, and they can be kept at room temperature, which means that when it comes to delivery, they don't need to be refrigerated, which will help reduce the costs. They also bind with a higher affinity and are a lot more specific, which is important when you're looking to remove specific things from the slurry. And because they are synthesized chemically, the scale-up production of aptamers is a lot cheaper and a lot simpler than it would be for things like antibodies. So how is the product going to work? So this is a mock-up of a general structure of an aptamer. And as Katie mentioned, we have designed ours for tetracycline, but really any antibiotic is fine. So it will bind tetracycline, and then we will receive the aptamers from the aptamer group, who will deliver them to us, and we will then bind these onto the surface of an inert material. And this material will be custom made to fit the shape of the pipes in the agricultural machinery, like this. So this is sort of a cross-section, and the slurry will then pass through the filter and hopefully come out clean the other end, because the antibiotics is going to bind to the aptamers, and this will reduce the amount of antibiotics present in the agricultural land. And one of the great things about our filters is that they are reusable. So they will be returned to us and cleaned with a special wash buffer, and this wash buffer can then either be autoclaved to denature the antibiotic, meaning it can be disposed of safely, or we are looking into the possibility of selling back this to the pharmaceutical companies to try and make some sort of profit. So how feasible is our idea? Well, we've been speaking to the business development executive at the aptamer group in terms of trying to figure out how feasible this would be. And they said that actually in terms of how feasible our idea is, they think it would be relatively straightforward to implement. And they have done similar things. So that's great. They have designed us a plan for tetracycline, which should be relatively straightforward to implement. And they have said that if you wanted to expand it to other antibiotics or indeed other sources of wastewater contaminants, then that would be relatively straightforward as well. So the opportunity to expand the company is great. So initially when we started thinking about our idea, we were concerned with who would actually buy the product, because antimicrobial resistance is something that affects everybody, but would the farmers actually be prepared to buy the filters from us if they're not seeing the direct benefit? So we considered the fact that it could be a potentially government-funded idea. So we've been in communications with the local MP for York Outer, Julian Sturdy, who has given us his full support for our idea, hypothetically obviously. And he said that it's something the government would be really keen to support, and this is this nice, slightly creased letter that he sent us. And he's actually in a really good position to judge our idea. He has a background in farming, and he also he's a chairman of the All-Party Parliamentary Committee on Antibiotics. So he has a real personal interest in our idea as well. And he suggested that the government would have sort of two routes of funding, either direct funding or through enforcing legislation. And we've taken the direct funding route with our idea and our budgeting. And so this is just a general overview of how we think the process will go from hopefully investment to product. So the Dragon investment will help pay for the startup, and Chris is going to go into more detail about this shortly. And then once we're kind of up and running, we'll get the first lump of government investment, and that will help us source the aptamers and build our filters. Our filters are going to be distributed by our special outreach officers, and they're sort of like salespeople, but they're going to help with delivery, the collection of the old ones, implementation, and actually helping the farmers with anything that they might want to discuss, any queries that they might have on how to reduce their antibiotic use on their farms. We will initially trial our procedure out in Yorkshire, and then the second lump of government funding will come after this to ensure that we can roll out the trial UK-wide.
Yeah, so I'm just going to go through some of the numbers and the finances. There are approximately 36,000 farms in the UK which use slurry as a fertiliser, and we aim to eventually provide all of these with our filter. A key part of our business are the outreach officers. We estimate there will be one outreach officer will cover an area of 1,000 farms, which works as roughly 4 or 5 farms a day. In terms of making the filter, the aptamer group will provide us with the aptamer, which we will then have to produce the physical filter and then conjugate the aptamer onto the filter. And we've planned to rent a small lab or factory space in which to do this. We estimate that the filter will cost about £7.50 to make per unit. Each farm will require 4 filters per year, which we will provide for a subscription fee of £100 per year. Once the filters have been used, they can sent back to the dwell, and we can recycle them using our washing buffer and then redistribute them back to the farms. We also plan on reclaiming any of the antibiotic bound to the filters, which we can then sell on to a third party for a profit. So we've allocated 5 years for the startup process, and that's just because that's typical for a biotech company. There's a long startup process. And we also need to negotiate and form a partnership with government and also an entire nation of farmers, so that can take a lot of time. The first trial area in the Yorkshire area, that'll cover an area of about 3,500 farms, which is about 10% of the UK total. We estimate that'll take about 2 years to do. Once that trial period is finished, we're going to scale up production and then roll out the AGRIPURE filter across the rest of the country. And we want to hit 100% coverage after 5 years from there. So we talked about getting the filter funded by the government. With 36,000 farms, that comes to a cost of £3.6 million per year, which sounds like a lot, actually is well within the budget that this government has been suggested spends on antimicrobial resistance. So we're asking for a £500,000 investment in exchange for a 25% share in the company. That cost covers a lot of the initial startup costs, including the patenting and the research and development. Using numbers we've estimated that the company will have a net present value of £2 million in 15 years, discounted at 10%, and that has an internal rate of...
You've just had 12 minutes, just
okay. And that's an internal rate of return of 25%. One thing to bear in mind is this projection is quite conservative. We've not accounted for some of the significant development and things we can do, including selecting for other antibiotics. This is just selecting for tetracycline. We can also use this filter in other sources of wastewater contamination, and we can also export this technology to other countries around the world. This is currently just the UK. So in terms of our IP, according to the European Patent Office, there are 15 patents associated with aptamers that recognise antibiotics. 2 of these are specifically recognising tetracycline. Our product differs, and we avoid competition with these current patents because our aptamer is developed in a different way. It'll be our aptamer, and also we'll be using our aptamer in a different process. Rather than usually these aptamers are used for detection or analysis, we're going to be using it for a large-scale removal of the target molecule.
So, okay, and finished in a timely fashion. Good. So we have lots of time, judges, for asking difficult and probing questions. My first question is, what happened to the other 2 members of your group?
We lost them along the way. One didn't turn up to the... both didn't turn up.
Okay.
One unexpectedly, one expectedly. So.
Okay. Young men are unreliable these days. Okay, good. But judges.
Who's going first?
Either of you?
Who's going first?
How much tetracycline is present in slurry? Do you know how much is in there?
Yeah, so scientific studies have shown that about 75 to 90% of ingested antibiotics can pass into the manure, so it can be quite high level entry into the environment. And they have shown the emergence of resistance in genes and soils because of the application of slurries containing antibiotics.
I was just wondering about the affinity of your aptamer and the filter. So do you know, like, per mil, how much you...
So some of the studies we looked at, the values range are sort of 7 micrograms per kilo of soil. So this is the value that we gave to Zada. We spoke to her at the aptamer group, and she said that the aptamers were more than efficient enough to detect that one.
Do you see any issues with using them in slurry?
I don't think so. How do you mean in terms of the viscosity or in terms of...
Yeah, it's just sort of, it's not a usual medium.
It's not, no, but actually,
So it's still water, is it?
No.
well, have you done some work with Slurry? So it's actually surprisingly liquid.
Yeah, it can be.
It's a little unpleasant, but it should flow very well, so you should be able to get good coverage. We can make the filters as long as they need to be to put into the ends of them, and they bind with such high affinity that it should clean them. Absolutely fine.
Okay, I've got 4 questions, so brief in the answers, please. Let's compliment your presentation. I thought, you give vision, the operations and statistics to back it up. So having complimented you, I'm going to come in with some probing questions. First of all, I've got no problem understanding that this is a challenge that needs solving. I'm happy to understand that you've supported that case, you made the case eloquently, very well done. Isn't the answer here, rather than filtering tetracycline out, not to put tetracycline into the system in the first place? Isn't that the way we should be going?
Yes, ideally, but I think the fact is if you have animals that need antibiotics, then animals need antibiotics, and if we don't have ones that are dissimilar to the ones that humans use, then we have no other option. So while that is obviously the ideal, that's kind of not how it is at the moment.
Okay, I'd like to think more about that, because I've heard about perhaps in Holland where significant reductions in antibiotic use have been made, and just as a challenge to your business plan, I think it's worth thinking about.
Yeah, I do think that's a good point, but I think the fact that our model, we've used tetracycline and other antibiotics, but I think because aptamers can be designed to be so specific, you can then expand it to other sorts of wastewater contaminants anyway. So while the antibiotics are an issue now, our product works great for that, and it means that in the future, if we wanted to expand into another area, then we'll be able to do that.
All right, thanks. Second question, and I think you, and I'd like to compliment you, alluded to it. I think this is a tough one in terms of the beneficiary versus the customer.
Mm-hmm.
So you either get the pharmaceutical company to pay, they see it as a cost, they don't really want to pay that. If you try and get any money out of farmers, that's a really tough thing to do. So I understand why you're asking the taxpayer to pay for it, but I think that's a tough call for politicians as well. Any answer to that?
Well, I think, you're welcome to read the letter if you like, just in case. But yeah, he said that, especially with the recent government review on antimicrobial resistance, it is something that they're really keen to do things with, and I think definitely in theory anyway, it's something that they'd be wanting to support.
Good job for doing that. Okay. Cost, I'm a bit sceptical. I mean, this sounds like an expensive high-tech sledgehammer to crack the nut. Aptamers is not a proven product yet. They're still trying to get into market for the high-tech applications. Is the cost really £7.50 per filter? That seems, I don't know, seems like a high-tech, potentially expensive solution to the problem, which is basically slurry, low-value product.
Well, the cost of DNA as a raw material is actually quite low. There's a lot of technologies which use DNA. You can order sort of custom primers for quite a small amount of money. So if we're producing the same aptamer on quite a large scale, that mass production brings the cost down quite considerably.
And also slurry actually ends up saving farmers a lot of money. So it could be seen as a low value product, but it produces significant savings for the farmer if they're not having to use inorganic fertilizers.
Okay, thank you. Last two very quickly. Great that you got some feedback from Aptamer, they support this. Perhaps to misquote, I can't remember, it's Christine Keeler, well they would say that, wouldn't they, because you're providing a route to market for them. Did you get any feedback from pharma companies and farmers about their willingness to pay?
Not farmers, no, we didn't, no.
Right. Last point, moving on. I just want to understand the maths about your investment. So you're looking for £500,000 equity investment, is that correct? And that's for 25% of the company. So I think that means you're valuing your company at £2 million.
Currently, yes.
Yeah, and you tell me that in 15 years' time the company's going to be worth £2 million, so I don't get any return on investment.
Well, there's an annual turnover of over £2 million a year.
Okay, so the value actually more than that.
Yeah.
Just worth looking at that because investors are very, very keen to understand that they get money back. If it's valued at $2 million now and you say it's valued at $2 million in 15 years, nobody's going to put money into that. I think it's just the way their numbers are communicated. Thank you.
Yeah, just really quickly on the
2 minutes.
on the logistics of it. You're going to be there's 36,000 farms. Remember, not target them all, but you've got to get the filters to them. Then you're going to get the filters back off them to clean them. That's quite a lot of logistics, and it's £750 a filter. There's not a lot of money in there.
That's why we're using our outreach officers. So they'll be basically our route of delivery and of collection, and they'll be kind of taking the role that a salesperson would normally take in a normal company. So a lot of you'd normally pay a salesperson things like petrol and general expenses like that anyway. So we've actually included all that pricing with that, and it means that we have the added advantage that they can help the farmers with any implementation that they need. So they'll take the filters from them, take any old ones back to us, and then we can keep on that process of recycling without actually having to incur much more costs. We don't have to do anything with the delivery, and because they have such a long shelf life, and because they can be kept at room temperature, the actual delivery is basically fine in the back of the car.
Okay. And next we have the purple team.